Hello and welcome back to my channel. So in the last video we had done we have proved some theorems. So in today's video we are going to do the same. We're going to prove an important theorem used in limits and trigonometry as well. So today we have to find the proof of cos x is less than sin x by x is less than 1 when x belongs or is in between 0 and pi by 2 mod of x. So in trigonometry we know that sine of minus x is minus sine x, because this is not symmetric about the y-axis, whereas cos minus x is cos x because this is symmetric about the y-axis. So let's make a circle. Let's start solving this problem. So here I've made a unit circle. That means the radius of this is 1. I've written 1 and 1 on both sides. So here OA and OC are 1. These are the radii of this circle. So here we can see there are three triangles. One is the OBA, right? This is the bigger triangle, and then we have OCA, the smaller triangle, and also then we have the sector OAC. So let's redraw these triangles. But here before I go to the next page, we can see that triangle OBA is occupying a lot of space, a lot of area. So that means the area of this one is bigger than the triangle OCA, as well as the sector. So here I have redrawn these triangles. Here first I have drawn this triangle OCA, and then the sector OCA, and then the bigger triangle OAB. And here I've written one, sorry, this is not 1, this is 1 because this is the radius of the unit circle. That's why OA is 1, OC is 1. So let's first write the area of a triangle is given as half of base into height. So area of triangle OAC is half of base into height, right? Which equals half times base is OA, height is CD. Now let's make a point D here, and so this is the height, right? This one will be the height, so CD. Now similarly, area of the sector is given as area of sector OAC is sector angle by total angle times area of the whole circle, that is pi r squared. So in this case we have sector angle is given as x radians, so we can write x. Total angle of the circle is 2 pi, and then area of the whole circle is pi times OA, which is the radius, square. And now then we have to find the area of OAB, which is again given as half of base into height. Area of triangle OAB is given as half of base into height, which is half of base is OA, and height, as you can see here, AB is the height times AB. Now as you can see, the area of OCA is less than OCA, the sector OCA, right? And then this one is less than the bigger triangle OAB. So we can rewrite this as half of OA into CD is less than x by 2 pi times pi into OA square is less than half of OA times AB, right? So here OA, as this is a unit circle, OA is 1 equal to 1, right? So that means this whole equality will become half of CD is less than yeah, as well as half. This one is common, half we can take it as a common, so it will become, it'll just be it will be CD is less than x times OA is less than AB, because here we can see that half, and here we have 1 by 2 is common, and OA is 1. So CD, then this will reduce to CD is less than x times OA is less than AB. So let's find the values of these, like let's try to find the value of CD and AB. OA we know, OA as well. OA is 1. So here we have x by pi here, wait a second, this OA so x by pi and pi will get cancelled, so we are remaining only with x here. So it will be x. So let's find the values of CD and AB. Now from these triangles, going back and looking at this triangle OAC, here we have this is the x radians, right? X. So here, applying some trigonometry, let's redraw this triangle here, OAC, right? So here we have D and we have a line here, and this is x radians. So we know that sine x is perpendicular by hypotenuse, or we can say opposite side by hypotenuse, right? So opposite side in this triangle is CD, so we have CD by OC. Now OC is 1 and OA is 1. So here so then OC, in terms of OC we can also write, so this becomes a OC times sine x is CD, right? So we get the value of CD, and OC is 1 because this is the radius of the circle. That means sine x equals CD, right? And now we have to find the value of AB, right? So from what triangle can we find that? So here we have the bigger triangle OBA, and let's redraw the big triangle like this. We have something like this, right? OAB, and here this is the x radians. So here we can't apply the sine function because sine is opposite side by hypotenuse. Hypotenuse, we don't know the value of OB. We need to find the value of AB. So we can apply tan function, right? So tan is opposite side by base. So we can write tan x equals AB by OA. So we know OA is 1, so that means, which implies that tan x is AB, right? So we got the values of AB and CD. So let's substitute them in this inequality. So we can rewrite this as, now CD is sine x, so we got sine x is less than tan x, right? Now dividing this throughout by sine x, we can write it as 1 is less than x by sine x is less than tan by sine is 1 by cos x, right? So taking reciprocals throughout, we get as cos x, we get the opposite, the reverse of this. Cos x is less than sine x by x is less than 1. And how do we get this? Is because when we apply reciprocals, the least one becomes the largest one, because if you have 1 by 10 is less than 1 by 20, right? Sorry, will be less than 1 by 20, but when we apply reciprocals, so then 10 becomes, 1 by 10 is greater than 1 by 20. So here I've done a mistake, sorry for that. 1 by 10 is greater than 1 by 20. So when we apply reciprocals, so 10 becomes less than 20. So likewise, if this is, it will be greater than 1 by 30, and when we apply reciprocals, 20 will be less than 30. So this one will become the largest value. So similarly for here, we have 1 by cos x, so this whole will get reversed, and we have cos x is less than sin x by x is less than 1. So we have proved this theorem. So in the coming videos, I'll be applying this, and we'll see how it is going to get applied in solving problems, making problems very easy. So thank you for watching, and please watch my other videos as well. Thank you.